Okay, this is Algebra 1, Lesson 27. We're going to talk about the distributive property and simplifying decimal equations. So let's look at this problem here. 4 times 2 plus 7. We said there's two ways of doing it. Please excuse my dear Aunt Sally, so we can do inside parentheses first, 9. So 4 times 9, we get 36. Or we said we can simply multiply, right? 4 times 2 is 8 plus 4 times 7, which is 28, and we add them together and we get 36. So we get the same answer regardless of which order we do. And we've done some simple problems like 4p times x plus 3y. We've distributed, right? 4p times x, we said it's 4px plus 12py. Okay, simply, those were simple. So now we can use the distributive property to do some little more complicated problems. For example, let's look at this one. If we have xy times y squared minus x squared z, okay, we have two terms inside of that parentheses. So we have to multiply everything outside to every term inside of the parentheses. Then you have to remember, what are your power rules of exponents? So basically you have xy times y squared minus xy, positive xy times a negative, so xy x squared z. Okay, now we have to combine these. This simply becomes x, y cubed, combine the x's over here, x cubed, y, z. But you have to remember, you have to have the same base, y and y. This is an implied y to the first times y squared, which gives you y cubed. You add the exponents. Here you have x to the 1 times x squared, the same base, and you combine the exponents, which is x cubed. Okay, let's look at another one. Let's look at another more complicated one. I don't know why this big glare is on here. All right, so let's look at this. If we have ay minus 4y to the fifth times 2x squared y. All right? Does it matter if it's on the right or the left? It doesn't matter because we have a commutative property that says we can switch them around. That means multiplication. So we simply take this and multiply by every term inside the parentheses. So you have 2ay x squared y. If you have a negative turn to positive, so it's a negative 4 times 2 y to the fifth x squared y. You cannot leave your answers like this. You have to combine. Do you have any more coefficients here? No, so it's simply 2. Any a's? No. Y's have got 2. They're to the implied first power, so it becomes y squared x squared. Minus 4 times 2 is 8. You don't leave it 4 times 2. And then you combine your y's. It's an implied 1, so it's y to the 6th x squared. And that's simply your answer. It's all it is just making sure everything outside is multiplied times every term inside. And you can't forget your negatives. If this was a negative 2x squared y, you'd be a negative times a negative, which that would make that positive, and negative times a positive, and this would become negative. So you can't forget your negatives. And also you can't forget your rules for exponents. How do you multiply exponents? You have to have the same base. Y and y is the same base. If there was not an exponent, it's an implied 1. You simply add the exponents and you keep your base. So it'll be y1, which is y squared. Okay, let's look at example 27.b, which is simplifying decimal equations. I don't know about you, I'd rather work with whole numbers than decimals. So can we do that? Can we change an equation? This is 0.4 plus 0 0.02m equals 4.6. And I'm looking at example 27.5 in your book if you want to follow along. Okay? Now, if we multiply every term by some power of 10, the coefficients become integers, yes? And remember we said if we multiply an equation, every term in the entire equation by the same number, we're not changing the equation. So we look at our decimals. You have a 0.4, 0.02, and a 4.6. Which one has the most decimal places? The 0.02. It's got 2 decimal places, or it's the hundreds. So that's the biggest or the most decimal places. So let's multiply this whole equation by 100. Now, there's one term here, one term here, one term here. You have to multiply every term by 100. So what's 100 times 0.4? You simply move it over. It becomes 40. Plus, this becomes 2m. This becomes 460. If you forget how to do that, you have to multiply by 100. There's 2 zeros. You move your decimal place over 2 places. And you multiply by 100. Now I have whole numbers. Now I can just simply solve this much easier. 2m equals 420 divided by 2. M equals 210. Then it makes it much easier. If I did it with decimals, I would get the same answer, except I'm more likely to make a mistake because we tend to forget our rules for adding decimals, subtracting decimals, and multiplying and dividing decimals. All right, let's look at example 27.6. It says 0.002k plus 0.02 equals 4.02. So again, we first of all, we start by writing our problem down, which is 0.002 k plus 0.02 equals 4.02. When you look at your decimals, which one has the most places? This one's got 1, 2, 3, 1, 2, 1, 2. So this one has 3, which is the biggest, which is the thousandth place. So we're going to multiply this whole thing by 1,000. Move the decimal place over 3 places. So 2k plus 20 equals 4020. Now we have whole numbers. Those are much easier to work with than decimals. I don't know about you, but for me, that's much easier to do in my head. Divide by 2 gives me 2,000. Okay, so the code for this lesson is going to be 300. Write the number 300 on the top of homework lesson 25. The code 300 on the top of lesson 25. Do your practice problems.